Let us look at what is cryogenic oxygen. Cryogenic oxygen is oxygen converted into the liquid form. For this, it is essential that the oxygen is converted into a liquid and stored below minus 183 degrees Celsius. In fact, minus 183 degrees Celsius is the boiling point of the liquid oxygen. So it has to be stored at minus 200 degrees Celsius or so that the oxygen remains into the liquid form. Now, what happens to the oxygen? How it expands? Let us look at it. In the liquid form, the oxygen is kind of compressed. So 1 liter of liquid oxygen is almost equivalent to 870 liters of gaseous form of oxygen. Or we can just say, as a thumb rule, more than 800 liters of oxygen is made available out of 1 liter of liquid oxygen at the atmospheric pressure. Now, pressure, temperature have a huge effect on the calculations of oxygen. So we are not going to go too much into the physics of it. We are looking at the oxygen's basic calculations so that you are able to understand oxygen. We can term this as oxygen calculations. So basically, when industrial grade oxygen is delivered or medical grade oxygen is delivered, it is measured into metric tons. 1 metric ton is equivalent to 870 liters of liquid oxygen. And 1 liter of liquid oxygen is equivalent to 876 liters of gaseous oxygen. Now, what is gaseous oxygen? In the simplest way, you take a vessel of 1 liter milk and the air that will be contained at atmospheric pressure into that 1 liter of vessel of milk is 1 liter of oxygen in gaseous form. So, there are 4 sources of oxygen which are used for giving the medical oxygen. Let us look at these sources and their categorization. First one is called liquid medical oxygen plant. These are huge liters where thousands of liters of oxygen can be stored at cryogenic temperatures. The second delivery source is a Duracylinder. These are transportable smaller vessels which store oxygen, but it can be 200 liters or 240 liters or 250 liters capacity of Duracylinders which store this oxygen in liquid and cryogenic form. The third portion, that is, are the normal jumbo cylinders in which oxygen is stored into gaseous forms. The fourth one is evolving in its adaptation. The technology has been around for a very long time, is the pressure swing absorption based oxygen generators which suck the air from the atmosphere, filter it using some aluminum silicates called zeolites and deliver 93 to 95% pure oxygen for the medical purpose or industrial purpose. Now, the cryogenic oxygen is only used in the first 2 types. Obviously, when it's going to expand 800 times, it requires a proper delivery mechanism. It requires a conversion unit. It requires pressure regulation because huge pressure is built up. Imagine it's going to expand 800 times. And even if you store the oxygen at the cryogenic temperature, you know there is perfect insulation is not possible. So the oxygen keeps on getting converted into gaseous form and the pressure is created into this high pressure vessel. So now once the oxygen there is an outlet from the LMO plant or from the Dura, there is a vaporizer that is required. What does vaporizer actually do? Vaporizer exchanges heat with the atmospheric air. Simply, it is having fins like we see our ACs or radiators are having fins, but in a very different and large proportions in the layman's language. This vaporizer, when oxygen is passed through it, will exchange heat with the atmosphere and the liquid oxygen will get converted into the solid into the gaseous form, while water will solidify and have ice accumulation, snow accumulation on the pipeline outside, because it's still very cold oxygen that has got converted into the gaseous form, because it's just the boiling point is minus 183 degrees Celsius. Now when this oxygen gets converted, it's a huge pressure, it's expanding, right? It's boiling and expanding. So to cut this boiling and expanding, we require pressure regulatory valves to step down the pressure gradually into the pipelines, so that the oxygen can be delivered to the ventilators and the oxygen points into the hospital. So to recap, liquid medical oxygen, there are huge pressure vessels in which oxygen is brought into the liquid form from the cryogenic tankers, and it is filled up, and further they are vaporizers and they will deliver it to the patient. If you look at Dura, I have explained the Dura technology. Again, liquid oxygen, cryogenic oxygen, use of inbuilt vaporizer or external vaporizer, and then delivered to the patients. Jumbo, it's the gaseous form, and the oxygen generators or oxygen concentrators. Now let us look at the capacity. As I told you, thousands of liters, KLs. The liquid oxygen is delivered in metric tons, converted into the KLs. The units have been explained, and to the recap, we are recapping it. The units have been explained to you as 870 times, roughly 870 liters, and then again conversion of 0.87 factor into the gaseous form. But if you look at the other portion of the oxygen, the gaseous form, the jumbo cylinders are B and D type of jumbo cylinders. So the larger ones, the type B, will store around 7,000 liters of oxygen, while type D will store around 1320 liters of oxygen, both in the gaseous form. These are also stored at a certain pressure and then delivered to the patient.